And continuing on with the implementation of our smoothing sculpt tool, Lee.
What, you're expecting somebody else this time? No. Sorry to disappoint you. It's me again. All right. Now, we've got our list of vertices. We need to make use of it. So what we're going to do is create a new variable called vertex keys. And our vertex keys are going to contain a new list. And this list is going to contain, or it's going to be of type vector 2. I probably should specify that first. So it's going to be a list of vector 2s. And inside of this, we're going to populate it with our vertices dot keys. So I'm just making a list of all the keys that are in our dictionary. Once I have a list of all the keys, I can go ahead and make a loop that will loop through for the total number of times of our keys inside our vertex keys. So I'm going to grab its count. Really, you couldn't figure that one out. All right. Once we've got that, I'm going to make another variable. I'm going to call this one vertex. This is going to contain the value that is in our vertex keys sub I. Now we need to do our distance check for our early out. So we'll do var distance equals our vector 2 distance. Now we're going to pass in our vertex, because if you remember, our vertex is the key of this element. Our vertex keys are all the keys that are inside of our vertex or our vertices dictionary, and the keys are vector 2. So this will always give us a vector 2. Now we're going to compare that, or get the distance between that and a new vector 2. The new vector 2 is going to be made up of our position dot x and our position dot z. So we're going to compare those two, get our distance, and then do our check like we've done in all the other ones that says if distance is greater than our brush size divided by 2, then go ahead and continue, because we don't need to worry about it. It's outside of the range of influence for our brush. But if it isn't out, or if it is inside the range of our brush, we need to smooth it. So in this case, I'm going to use a try to make sure that we don't catch any errors, or that we do catch any errors, particularly if we look outside of the bounds of our vertice dictionary. So what we're going to do here is just throw a debug dot, I could do a log, but we use that log error, so let's do that again. That's fun. It says something went wrong while smoothing. I will get the right key eventually. All right. So now, inside of our try, we need to create a whole bunch of variables to keep track of stuff that we're looking for. The first one is going to be fs. This is our full space that we've been using a lot in other methods for other classes. So we're going to take our integer, we're going to parse it by our config.setting. Really, you can work with me, ReSharper. It's okay. All right. So config.setting, and inside of this we are going to be looking for our patch vertex spacing. So we're basically just trying to figure out what our spacing is. Then we're going to take our new variable, call it HF or HS. This is our half space. So this will be full space divided by 2. So that gives us a half space. Now, if you remember way back when we were doing smoothing in the terrain generator, we're not sampling a square. We've got a hexagon that we need to sample from. So a hexagon has 6 surrounding points. So we need to sample all 6 of those points. So we're going to have our upper left point. This is going to equal our vertices. And we're going to do a lookup based off of a new vector. This will be a vector 2. And for our x component, we're going to use vertex.x minus a half space. And we're going to use vertex.y plus a full space. This will give us our upper left sample point. And the only part that we really care about is the height there, so we're going to look for the y component. Now, this is going to be the same thing that we do for the other 6 points. Those points being the upper right, the left, the right, the lower left, and the lower right. Now the difference for each one of these is for upper right, instead of minus a half space, it's going to be plus a half space. Left is going to be, it's going to be a minus a full space. Y is going to be on the same plane as the vertex itself. The right is going to be plus a full space. Again, it's going to be on the same Y plane. Lower left is going to be minus a half space for the left, minus a full space for Y. It's going to be, or upper or lower left is going to be a minus a full space for Y, and it's going to be plus a half space in X. Those will get us our 6 sample points. We need to get the average of those. So a new variable called AVG for average is going to be equal to our upper left plus upper right plus our left plus our right plus our lower left plus our lower right divided by 6. So that will give us our average of those 6 sample points. We need to get our sample point like we did with the other tools. So we'll calculate our sample point being a new vector 2. And to build this vector 2, we're going to take our vertex.x minus position.x by vertex.y minus position.z. Once we've got our sample point, we can get our weight or our sample weight. So we'll get our sample weight by calling our brushes.sample. We need to pass in our sample point, and we need to pass in our brush size. Now, to what we get returned back out, we have to multiply our strength. Once we have all that information, we can then calculate out our height, Our height is going to be the lerp of our vertices at vertex dot y. So we're going to take our existing height and we're going to blend that with our average by a ratio of our sample weight. So that will calculate a new height that is going to be somewhere between our existing height and the average of the other 6 points.
Okay.
Once we've got that, we can take our vertices at element vertex, set that to be equal to a new vector 3. We're going to build out our new vector 3 using our existing vertexes x and z. So here's the x, here's the z, and we need to assign a y. Our y will be our height. So that will reassign our current vertex's height based off of the average along with our sample weight that comes in from whatever brush we may be using at that point in time. This will go through and calculate all of the new vertices, but if you remember, the vertices that are calculating are stored inside of this dictionary. They have been completely decoupled with the patches that we started off with. So we have to go through and reassociate the correct vertices with the correct patches to give them their new heights. And that's what we're going to cover in the next video.
Awesome. Okay, well with that, that is going to wrap up this video.